This is example 7.8 from Discovering Design with Chemistry. TiO2 is a white pigment used in some types of paint. One way it can be made is through the following chemical reaction. 2FeTiO3 plus blah, 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 blah. I've colored these to match things in the question, and I'm going to try to use pen colors to match so that I can leave out some of my things that I probably should write to make this more easy to read. If you have 15.5 kilograms of the red one and excess of the purple ones, how many grams of the green one can be made? So I've highlighted the ones that matter. If you have this in your comprehension check, the different ones you do that, you can also put a box, a star, colored pencils to help you mark different things to keep your stuff straight. Because HCl and Cl2 are excess, that means we're going to use all of the FeTiO3. They told us they were in excess so that we know that the FeTiO3 is our limiting reactant. That's going to determine how much we make of everything. So we don't even really have to worry about the purple ones, so we're not going to do anything with those. The ones that are still in black, they don't even refer to in the problem and ask us about, so again, we're not going to worry about those. But because we know we're starting with FeTiO3 in a certain amount, and that amount is the amount that's going to be used, all of it, and we know that we're going to produce TiO2, and that's the one that they're asking us how many grams we're going to get out of it, let's go ahead and find the conversion relationship of those. So we're going to add up the amounts of the atomic mass for each of those different chemical formulas so that we can figure out how many grams is in 1 mole of FeTiO3 and how many grams is in 1 mole of TiO2. That way we can kind of skip some stuff later. So for FeTiO3, so let's find Fe and Ti and the O. All right, so we have 1 Fe, so that's 55.85. And then we have 1 Ti, so that's 47.87. And then we have 3 oxygens, so that's 3 of the 16. This answer is going to give us the mass in atomic mass units for this molecule. You know what, I just realized I wrote in the wrong color. Boo. I thought I had the red selected, but I didn't. I'm going to fix that real quick because that will make it easier to read if I have it in the right color. Red. Yes, I want to use red. Okay. So 55.85 plus 47.87 plus 3 times 16.00. All right, so this will give us the atomic mass unit of the FeTiO3, and that means that number that we get will also tell us how many grams makes 1 mole. So 55.85 plus 47.87 plus 3 times 16. All right, so that gives us 151.72. So we know that 1 mole of FeTiO3 is 151.72 grams. Now, they've actually given us the number in kilograms. Boo, why do they do that? Because that means we have to convert it to grams before we can work with that. So we'll come back to that when we're actually starting to work with this. Right now, we're just getting our conversion relationship set up so that when we're ready to use them, they're ready and easy to find. Okay, so for the other one, we need Ti, which we already have right here. We already found it first, and O, oxygen, which we also already found. So we have 1 Ti, so that's 47.87, and we have 2 oxygen, so 2 times 16. So that's 79.87. And that's in AMU, but of course what it tells us is that 1 mole of TiO2 equals 79.87 grams. That is going to be a conversion relationship that we're going to need. The only other conversion relationship that might be helpful here is to recognize that in this problem, I'm going to scoot this over because we're kind of done with the periodic table and this will give me more room to write. is that for every 2 of the FeTiO3, we have 2 of the TiO2. That means we use 2 moles of the thing that we have 15.5 kilograms of, and we get 2 moles of the thing that we're actually trying to figure out. So that means however many moles we use of one is the same number of moles we get of the other. So I'm not going to do a conversion relationship, I'm not going to do the little equation thing where I convert it because I know the numbers are going to be the same. All right, so let's get started. All right, so I have 15.5 kilograms of, I wonder if I have a pen that's that color. This one looks kind of close. Let's try that one. Okay. So I have 15.5 grams of FeTiO3, and I want to convert that to grams. Well, to convert kilograms to grams, you can either do it using the move the decimal trick you may have learned in elementary school, or you can set up a conversion factor. How many grams is in a kilogram? In 1 kilogram, there are 1,000 grams. The kilograms will cancel out, and that will leave you with the number of grams. So that's 15,500 because we've moved the decimal place 1, 2, 3 times. Okay, so now that we know how many grams we've got started with, we can turn this into moles. Because remember, when we're doing our little thing, let me write this over here. We start with grams. We have to change it to moles. We work in moles doing whatever we need to do. We get some different moles, and then we convert that back to grams. In this case, we actually started with kilograms, and we had to go to grams first. So, and this is our work. So let's convert this to moles. So 15,500 grams. And this is, sorry, I sort of changed colors here. This is the FeTiO3 color. So we're going to convert this into moles. So we want grams on the bottom, and we want moles on the top. And I'm not going to write my FeTiO3. That's the whole point of me using the colors. So 1 mole of that is 151.72 grams. Now, this number has 3 significant digits. The other has 5, so we're going to get 3 in our answer. So 15.50 and divided by 151.72. All right, so we can only keep 3 of these, so that will be 102 moles. So that's how many moles we have of this. It's 102 moles. So when they told us that we have 15 kg of this, what we actually have is 102 moles of this. And because this has a 2, and the thing we want has a 2, I could line this up 102 moles times, and then my conversion relationship would be 2 moles of this one on the top and 2 moles of the one I'm getting rid of on the bottom. And then when I multiplied it, 2 over 2 is just 1, and so I would still get 102 moles. So this one, I'm going to get 102 moles of that. So does that make sense? I use this to recognize that however many moles I have of one is how many moles I'm going to get of the other. What I have to figure out now is what that means. So I'm going to get 102 moles of the green one, the TiO2, but I've got to convert that into grams because the problem didn't ask me how many moles of TiO2 can be made. It asked me how many grams of TiO2 can be made. So we're going to take this and we're going to convert it into grams by using the conversion relationship. I'm working with TiO2, so I'm working with the green one. So this is the conversion relationship that matters. So for 1 mole, that is 79.87 grams. And once I do this, I'll know how many grams I'm going to get. So 102 times 79.87. Now I have 1, 2, 3. I have 3 significant digits for one and 4 significant digits for the other. So I can either put this number in scientific notation, or I can just round it and leave zeros after the first 3. So for example, I only need 3, so I only need 8, 1, 4, and then obviously I have to have a ones place, but I can't have anything significant in it. So I can round this to 8150, or you can write it in scientific notation with 8.14 times 10 to the third. The answer in the book just rounds it and just puts a 0 in the ones place and rounds that tens place up to a 5. But either way is fine. Written like that, written in scientific notation, as long as you get 8,150 grams and as long as it only has 3 significant digits, then you're fine. You got the problem. Again, you can stop now if you understand what I did. If you are not sure if you could repeat that, let's review real quick. We were given a problem. We were given some nice extra fluffy information up here about what this thing is. Don't let that part of the problem confuse you. That's just to make a real world connection and to make it interesting, but it's not significant to solving it. The significant thing is the chemical equation that they give you for that chemical reaction, and then the starting amount of what they've given you. That's important, and what you want is important, figuring out what it is that you're trying to aim for. Once you have those pieces of information, what I like to do is go ahead and make my conversion relationships from the beginning. Mine looks a little messy because I've been marking all over everything. But what we did was we did the conversion relationship for the first one. Oh, oops, I took out some numbers here. We did the conversion relationship for the FeTiO3 and put a box around it so we could find it. Then we did the conversion relationship for the TiO2 and put a box around it so that we knew how much, for 1 mole of each of those substances, how many grams would it be. Having that figured out and having a box allows us just to work straight through the problem without having to go back and forth and keep recalculating new things. Recognizing that there were 2 moles of the FeTiO3 involved in the reaction for every 2 moles of TiO2 in the products helped us to know that we had the same number of moles of this one and we're getting the same number of moles because they both have a 2. If one had been a 2 and the other had been a 3, we would have needed to use a conversion relationship to figure out how many moles we needed to start with of our product to convert it into grams. So we started with one number, we converted it into moles, we figured out how many moles we needed of a different number, and then we converted that different number back into grams. The only thing I didn't mention just now is that because they gave us kilograms, we had to do an extra little conversion at the beginning, but that's not a very hard one. Again, this is an important concept and it's used over and over again in the next chapter and in subsequent chapters, so make sure that you understand how to do this. Make sure that you kind of can follow a plan and make a roadmap for yourself or follow the little mole roadmap in the book.